Here we're gonna have the Chemistry 2018 Unit 1, Paper 1. I noticed on this paper that questions 20, I believe, to 25 are missing. So if you guys have the questions, feel free to send them, and then I'll work them and give you the answers to them, and then I'll probably edit it to the end of this video. But let's just start the 2018 paper. Now, most of these are repeats, so I'm gonna be going through some of the extensive working questions, like working out questions, right? And you guys can watch the videos that I worked them in, right? So we're looking at this. We want half-life best suited for tracer in medicine, right? So it needs to last for a good while, but you don't want it to last for an extremely long while. Right, so it's around 15 hours should be fine. Element P is most likely sodium, because we're seeing that the first ionization energy is a huge leap. So this is a group 1 element, and sodium is the only group 1 here. 3. Which of the following pairs of elements combine to create a perfect X in Y type of formulae? Right, so we're looking for the ones that match perfectly. Sulfur and sodium would be out. Sodium and nitrogen would be out, but magnesium sulfur seems fine. 4. Which of the following solids has a giant molecular that is silicon dioxide? This yellow metal is a type of alloy brass used to make ornaments. It contains 60% of copper and 70% zinc by mass. How many moles of zinc atoms are there in 260 grams? Right. So let me see if I could work this here. So there's 260 grams of this, right? We're looking for zinc atoms, right? 40% of 260. So 40 divided by 100 times 260 should be 104 grams, right? And we're looking for the moles of zinc atoms, right? Right, looking for the moles of zinc atoms. I'm not sure if we get a list of any information while doing this, but I think the molar mass of zinc, I think the molar mass of zinc is around, how would it be, around 65 there, well, so I think it's around 65 point something, right? But let's work with 65, right? So if we have the molar mass 65, and we have the mass, so it's going to be, in order to find the moles is mass divided by the molar mass, right? So we're going to have the 104 that we got from the 40% of 260, and let me see if that would give us an answer. Divided by 65, does it give us an answer? 1.6, right? So what I did was find 40% of this. It should give us 104 divided by 65, and I got this, right? X here would be 104.5, right? Here is our P. We're looking at Avogadro's law there. The maximum mass of lead atoms, alright, so we did this already as well. So the answer would be 8.91, right? We looked at the answer for this as well. This needs to be experiments, it should be replicable, right? And that, so it should be around B. Deviations from ideal gas law behavior, right? Low pressure and pressure and high temperature, right? We've seen this question as well, and let me see something. Would be this. Hold on, let me check something. We're going to be adding that. What was the answer for this again? Let me think. First of all, let me look here. Poof, this is wrong. I think this would be wrong as well. This should be a product, so D. Here we did this question as well. B is the answer for this one. Here we did this answer as well. Here we did this answer as well. So as you can see, I worked backwards, so there's gonna be a lot of repeats here. Here the copper metal deposited and copper metal would dissolve because there's gonna be oxidation happening on the copper and it's gonna lose electrons and create copper 2 ions within solution, which are blue. So hold on. Copper metal deposited, and yeah, so it should be done. To be turned blue. Here this is repeated, so we know that for A it would be second order, for B sorry about that, for B it would be first order, so 1 plus 2 is going to give us I'm moving too fast, 3D. Right, here we looked at this as well. We're measuring carbon dioxide gas. So calcium carbonate and dilute acid, so we're measuring carbon dioxide gas. So the gas syringe is the best way to go. Here now we're looking at the rate. So we're looking for the units of K. So the unit is usually mole, right, per dm cube per second. Right, right, so the rate is usually in mole per dm cube per second. Right, so I'm not sure if that would just be the answer here, so let's look at the rate unit here. So K, what are the units of K specifically here? So K is the rate constant, right? Rate constant is usually in moles per dm cube. Let me see something here. I think it will just be the mole per dm cube per second because it should give us back that unit. Let's see first. Let's see something first. So let me just try to work it out real quick. Alright, give me a moment, let me work up to see what's happening. So alright, so the units of K, how do we work the units of K for this? Alright. Okay, so K should be around mole per dm cube. Then we have mole per dm cube squared. Alright. So I think for this question, right, where we have to find yeah, let's look at the concentrations first, right? So if we have the rate to be mole per dm cube per second, right, and we don't have K, and here we're gonna have K times, this is gonna be squared, this is gonna be regular, so it should be a what, mole cube, right, per dm cube, 12 dm to the 9th, right? So if we're gonna find K, we're gonna divide, I believe, right? Wait, hold on. We're gonna divide it like this, mole cube dm 9. Right, so let me move this down here. We're going to be having mole per TMQ per second divided by mole Q TM to the 9th. Right, so if we do it like this, we're going to have that canceling this, giving mole squared. Right, and if we're dividing, what do we do with the indices? We are gonna be minusing the indices, right? So I think here we're gonna have -3 minus what's 9, or is it 9 minus -3? Let me check. 9 minus -3. That should give us 12. Let's just cancel it out. If we cancel it out, we're gonna get, all right, so if we cancel it out, we're gonna get what, 6? Oh, it's gonna come into 3 times, so we're gonna get dm to the 3rd, and then if we move it up now, we're gonna end up with mole -2, right? Tm -3 per second, right? So do we have that? Okay, A would be the answer. Sorry for taking that long. 19, which of the following statements does not refer to a system dynamic equilibrium? So I believe that B would be the best answer for this. Alright, let's go down and look. So I told you that around 20 to 25 is missing. So if you guys could get these right for me, I'll do them and attach them to the end of the video. Which of the following pairs would be good buffers? We established it to be this. Not any of these. These are strong acids, and I don't think this would be a good buffer system. We looked at this as well. This is a repeated question. This is also a repeated question. Alright. This is also a repeated question. Alright. Standard hydrogen half cell. A platinum electrode is used to, what is it used to? Release hydrogen gas into solution. Not really. Act as an inert metal for the connection. Okay, could be. Allow, but no. Reduce the surface area. No, it increases surface area. So B would be the best answer. Alright, so there are 8 elements in the 3rd period. Right, okay, so which one would the diatomic molecule? So you know that diatomic molecules would be the halogens, chlorine. Here now, which of the following of the 4 substances would be the oxide of sulfur? Right, so oxide of sulfur would be an ionic, no, sulfur dioxide. This is interesting. So sulfur dioxide is it's an oxide of sulfur. So it could be sulfur monoxide, sulfur dioxide. What is the state of sulfur dioxide? What do you guys think about that before I answer this? State of sulfur dioxide, what is it? Okay. It would be a gas, I believe, and sulfur monoxide. State of sulfur monoxide, I think it should be a dilute gas as well. Therefore, the bondings should be either covalent or it should be a gas, right? The pH, sulfur is going to be acidic. Alright, so I think D is the best answer. I might have a mix up with something on the 2019 paper, so please point that out. 33, which of the following elements reacts very slowly with cold water and burns that wonderful magnesium? Calcium carbonate decomposes at lower temperature. We are saying that calcium oxides are, wait. If the calcium carbonate decomposes at lower temperatures, Yeah, the oxide is gonna be more stable. Ooh, I think this would be the standard enthalpy of formation. The more I look at the questions, the more the ideas about the questions change. Not sure if that happens. I think I may have made another mistake here. Hold on. If it decomposes readily, it means it's going to a stable state. Right? So the standard enthalpy formation is oxide less than the pure amongst it. That makes sense. So I'll comment on the other video, alright, for 2019 and see what's happening there. The high melting point of graphite can be attributed to the Are there strong covalent bonds within the layers? No, not necessarily. Delocalized electrons? No. I think it's the hexagonal arrangement of the carbon atoms. Right? Which of the following element has the highest? Is it covalent bonding within layers? Because don't they have the hexagonal thing? And they have like some amount of bonding between the layers allowing for it to be sliding. Is it delocalized electrons? Does this graphite have delocalized electrons? I don't think it does have delocalized electrons, I believe. So does that contribute to melting points? So why it does have delocalized electrons? So we're looking for why does graphite, right, have a high melting point? What do we think? I think it's because of strong covalent bonds, to be very honest. Yeah, let's go with that. Right, because we're looking at that. Okay. Have to refresh my brain from CSEC knowledge. 36. Which of the following elements has the highest electronegativity? This would have been sulfur. The Pauling's electronegativity of sulfur would be higher than all the others, I believe. In the table here, which would be the most stable, the one with the highest bond energy, I believe. Yeah. Which of the following transition elements have unpaired? Okay, chromium. Here we're talking about force orbitals only, I think. Right? So the thing is, fuzz increase from copper to zinc. The only difference would be the major difference would be the filling of the force orbital, right? Because I think it's copper. Is it cobalt and chromium? Copper is a filled 4s. So a sharp increase from copper to zinc is caused by filled. Why does it say 4D orbitals though? What orbitals are present on the zinc? So zinc has a 4s orbital and a 3D orbital. So I don't think. No. I think it would be a filled 3D orbital, but it hasn't gone to 4D. So copper sulfate gives this. Alright, so a deep blue solution with forms a complex there, and a yellow green solution with that. Alright. In excess concentration. Alright, so which of the following deductions can we? So we're saying here that complex here is formed. This is higher stability than that of the water, right? And has a lower stability of No, 1 and 2. Because if this is formed, wait, hold on. No, this would be true as well. Right, because if this is formed, this would be the deep blue. Right? Here, it forms this because it has a high stability than water, so this is an automatic given as well. But if we're going to say a yellow-green solution with excess concentrated nitric acid, that means that this complex is less stable than this complex, wouldn't it be? Right? Because the yellow-green solution remains itself, which is hydrogen chloride. Because it should give us a blue color with copper ions, the copper hexahydrate, right? Or aqua copper, right? 41, which of the following statements describe the trends in physical properties of the halogens as the group descends? Right, so that doesn't happen. No, volatility doesn't increase. The color deepens and electronegativity decreases. I believe that it's so. Corresponding decrease in density change. The color does deepen. There's a corresponding decrease in density. True. As a state. Okay, so we should have physical properties. Physical. I just saw it. And okay, here. So the lead ions can be found through D, zinc found through A, and 44 we have the lead and the aluminum ions can be found through B. Right? I don't know about that. Okay. So silver ions was added to a known solution. A white precipitate was formed. Alright. So a white precipitate was formed. So that bromine would be bromine, not bromium, but bromine. Alright. Would give us a silver bromide would give us a creamish. Alright. Iodine would give us like would that be the white solution? With the silver halides, colors of silver halides. So you need to remember the colors of silver halides. I would believe that the white precipitates would be the chlorine silver chloride. So let's go with that. Right? And that's the end of the 2018 Chemistry Unit 1, Paper 1. Right? So that's that.